Hello everyone, this is Team HC3 and we are solving the landslide problem. A landslide can be defined as a movement of rock, earth or debris down a sloped section of land. Landslides are caused by rain, earthquake, volcanoes and various other factors that could make the rock unstable. They can be accompanied by heavy rains or even followed droughts. The impact of landslides are pretty extensive, including loss of life, destruction to infrastructure, and even damage to land and loss of natural resources. Landslides can wipe out a large tract of forest, destroy wild habitats, and remove productive soils from the slope. So, more about landslide prevention from Tanya.
One of the quickest and the easiest ways to prevent a landslide on a slope is to vegetate it. This slope vegetation method works best on slopes that are not too steep or if the movement hasn't already begun. We can also use a solid, well-designed retaining that is made up of sturdy materials such as masonry, stone, brick, or steel. Drainage materials behind the wall help increase the stability of the wall. For temporary prevention, sandbags can also be used to divert water from uncontrolled spilling, such as retaining walls or diverted pathways too. Another temporary method to protect unstable areas is covering them with plastic sheeting, tarps, or even burlaps. Now, this is the model that we made, our solution for the landslide arrestor, and Shashank will explain it.
Yeah, thank you, Prince and Tanya. So now we have come up with a solution to tackle the problem of landslide and soil erosion, and also taking care of the environment in a meticulous fashion. What we have done is our model is very simple and lucid. We have divided the Lynn Hill into three different regions. As you can see in the model, the first region, that is the topmost region of the hill, we are going to be installing geowebs. Now, geowebs are made up of high density polyethylene. Okay, so geowebs are very strong enough to hold the soil intact and make sure that the upper part of the soil is not lost, and there is no the soil is not susceptible to any kind of movement, because the major source of landslide is the loss of the top part of this topmost part of the top layer of the soil, and which results in a movement of the land. So this will not take place because of the installation of geowebs. Now in the second region, we have installed highly tensile steel meshes. And these steel meshes, we are going to be installing, we are going to make it of high density, corrosion resistant, low carbon steel. So you don't have to worry about the steel getting corroded, because these meshes will stay strong, and they'll also be highly durable because they're tensile. They can last up to 100 years. And in the third region, we are going to be we are going to leave it free for vegetation, that is growing of crops, shrubs, and trees. The major crops which we can grow in high altitude regions are, we can grow crops like potato, tapioca, sweet potato, colocasia, turmeric, ginger, and tea, coffee, rubber. You can also go with berries. These are the ideal crops which can be grown in the lowermost part of the hill region. And now the benefits for this is that vegetation helps in increasing of the infiltration capacity of the soil. So this basically solves one big issue, and that is heavy rainfall. Due to heavy rainfall and low infiltration capacity of the soil is unable to retain most of the water. This results into a flooding, and also in the movement of soil, which ultimately results in the occurring of the catastrophe landslide. So this will be completely taken care of. At the same time, this also solves the environmental issues, and also the food scarcity in the hilly regions is being resolved by this. Now in the middle layers, we are in the topmost layer. We are adding geowebs. The major reason is geowebs are very efficient to use, and they have a very good sophisticated network of making sure that soil doesn't move, but they're very expensive to install. Even in a small part of the hill region, these geowebs are quite expensive to install. So we are only installing it at the point where the region of the hill which is highly susceptible to landslide, where landslide occurs a lot, where the movement of soil is the most. That is the one place where we're going to be targeting and using geowebs. In the second middle region, we are leaving it to steel meshes. The reason is steel meshes are more economically cheap compared to geowebs, and they're also equally strong. And the biggest important thing is that these are made up of high density, corrosion resistant, low carbon steel, so they are not going to get corroded, so they're going to stay strong. They'll be adding extra safety to the middle region of the hill, which is a bit less susceptible to landslides and the movement of land. So this is what we have come up with. So thank you everyone, and this is a model made by HC3 team, and the team members are Shashank Iyengar, Prince Samuel, and Tanya Sharma.